11.5 conclusion. When the dependent variable big Y is binary, the population regression function is the probability that big Y equals 1, conditional on the regressors. Estimation of this population regression function entails finding a functional form that does justice to its probability interpretation, estimating the unknown parameters of that function, and interpreting the results. The resulting predicted values are predicted probabilities, and the estimated effect of a change in a regressor big X is the estimated change in the probability that big Y equals 1, arising from the change in big X. A natural way to model the probability that big Y equals 1 given the regressors is to use a cumulative distribution function where the argument of the cumulative distribution function depends on the regressors. Probit regression uses a normal cumulative distribution function as the regression function, and logit regression uses a logistic cumulative distribution function. Because these models are nonlinear functions of the unknown parameters, those parameters are more complicated to estimate than linear regression coefficients. The standard estimation method is maximum likelihood. In practice, statistical inference using the maximum likelihood estimates proceeds the same way as it does in linear multiple regression. For example, 95% confidence intervals for a coefficient are constructed as the estimated coefficient plus or minus 1.96 standard errors. A section on James Heckman and Daniel McFadden, Nobel laureates. The 2000 Nobel Prize in Economics was awarded jointly to two econometricians, James J. Heckman of the University of Chicago and Daniel L. McFadden of the University of California at Berkeley, for fundamental contributions to the analysis of data on individual firms. Much of their work addressed difficulties that arise with limited dependent variables. Heckman was awarded the prize for developing tools for handling sample selection. As discussed in Section 9.2, sample selection bias occurs when the availability of data is influenced by a selection process related to the value of the dependent variable. For example, suppose you want to estimate the relationship between earnings and some regressor, big X, using a random sample from the population. If you estimate the regression using the subsample of employed workers, that is, those reporting positive earnings, the ordinary least squares estimate could be subject to selection bias. Heckman's solution was to specify a preliminary equation with a binary dependent variable indicating whether the worker is in or out of the labor force, in or out of the subsample, and to treat this equation and the earnings equation as a system of simultaneous equations. This general strategy has been extended to selection problems that arise in many fields, ranging from labor economics to industrial organization to finance. McFadden was awarded the prize for developing models for analyzing discrete choice data. Does a high school graduate join the military, go to college, or get a job? He started by considering the problem of an individual maximizing the expected utility of each possible choice, which could depend on observable variables such as wages, job characteristics, family background. He then derived models for the individual choice probabilities with unknown coefficients, which in turn could be estimated by maximum likelihood. These models and their extensions have proven widely useful in analyzing discrete choice data in many fields, including labor economics, health economics, and transportation economics.